Today's lesson is Glenco Chapter 8, Lesson 4, Multiple Representations of Functions. So we're on the real world link on page 603. It tells us that a group of friends are going to the museum, and each friend must pay an admission price of $9. So the first thing we need to do is complete the table, and then we're going to graph the ordered pairs. So if it costs one person $9, how much will it cost for two people to go to the museum?
$18.
And how much will it cost for three people to go to the museum, Nadia?
$27.
Thank you. And how much for four, Emma?
$36.
Okay, so now we're going to graph the ordered pairs. And this will be X and Y. So our ordered pairs will be 1, 9, 2, and 18, 3, and 27, and 4, and 36. So we'll go to our graph, start at the origin. We follow the x-axis first, so 1, and then we'll need to go up to 9 on the y-axis. Our next ordered pair is 2 and 18. Start back at the origin. Go to 2 on the x-axis, and then we'll need to go up to 18. 3 and 27. And 4 and 36. Okay, will this be a linear equation?
Yes, ma'am.
Because it will form a line. All right, so what equation did we use to find the total cost depending on the number of friends? Seth?
9x.
Sure, okay. So sometimes the book happens to use n because I think in their table they said that the total number of friends was going to be n, I guess n for number. And so the total would equal $9 each times the number of friends that are going. All right, now on your own, see if you could list the ordered pair for the cost if 5 friends go to the museum. What is the cost if 5 friends go to the museum? Jaden. So, what would the ordered pair be in this situation? Emma?
5 and 45.
Correct. Today's lesson, you're going to have to look at many word problems, and you'll be finding the equations in order to solve those problems. So let's look at page 604. On example 1, it says the drama club is holding a bake sale. They're charging $5 for each pie they sell. Write an equation to find the total amount earned, which will be T for total, if we sell P representing pies. All right, so our total will equal what, guys? It's $5 per pie. If it's $5 for each pie, what operation should we use? Seth?
15.
What operation? multiplication. All right, so if we take the number 5 and we'll multiply it times the number of pies, which is p. And remember, if you just put the number right next to the variable, that means multiply. Okay, on example 2, it says in a science report, Mia finds the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths, which will be B, that a non-active person takes in the variable M for minutes. Hey, pay attention on these word problems. They're giving you the variables they want you to use. So when you're plugging these answers into Canvas, make sure you're using those same variables, please. All right, so B is the number of breaths, M is the number of minutes. The number of breaths is 14 times the number of minutes. All right, what do you think, Jay?
B equal B.
The number of breaths will equal 14 times what?
Times B.
The number of minutes. The number of breaths will be 14 times the number of minutes. All right, so let's try these on your own. Look at A and B. A says a mouse can travel 8 miles per hour. Write an equation to find the total distance, which will be D, a mouse can travel in H hours. Try that one, please. All right, did anybody come up with an equation? Shelby, what do you think?
D equals 8 times H.
Perfect. Okay, what about B? Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies, C, that she can make in H hours. Hannah.
H equals 36C.
Well, remember, it's the number of cookies. It will be your total. So you're really, really close. The number of cookies that we can make in 36 hours. So you were really, really close. All right. Why are your hands still up? Okay. Let's look at page 605. All right. On examples 3 and 4, we've got some more tables because we love tables so much. And so we have tables. We'll have X and Y. We'll find the functions, and then we'll graph ordered pairs. Those examples are written for you in the book, so let's skip over to 606 and work one together. Okay, so it says, while in normal flight, a bald eagle can fly an average speed of 30 miles per hour. All right. So we'll need to write an equation and make a function table to show the relationship between the total distances, which will be D, that a bald eagle can travel in H hours. Okay? All right, told us hours was going to be H. And distances in miles will be D. So, on this example, we are coming up with any variables like we did yesterday. So I think we should pick low numbers. They'll be easier. Well, no, we don't want to use 0 today because you wouldn't have the eagle flying 0 hours. It won't really work to give you what you need. All right, so just stay real low. Page?
2, 3, and 4.
You could.
1, 2, 3.
I'm going to keep it even lower than that just because we're going to have to count by tens on our graph, and I don't want it to get too big. Let's just go 1, 2, and 3. Okay, so what equation will we be using to find the total distance? Remember, the bald eagle can fly 30 miles per hour. So that means 1. That's a unit rate. So here's 1 hour. So what will go here?
30.
Okay, so now look at the relationship here. What do you think, Seth?
60.
Okay, for the next number, I agree, but what about the equation that we're using? He's right, it'll be 60 next. Lily? The distance, make an equation. We've got to do the whole thing, right? The distance is going to be D, will equal, finish it up for us, Emma.
38H.
30 times H, and which is just smash them together. All right, so then what will this last number be, Kendall?
9.
Okay, so there we've made the table. Now it says to graph the ordered pairs. All right, so the first number will be X and the second number will be Y. So let's write our ordered pairs. X and Y, or in this case H and D. So 1 and 30, 2 and 60, 3 and 90. Paige, do you see why I wanted to go ahead and keep you away from that next number? Okay. It would have been really far. So in your book, there is a graph already made for you. So if you just want to plot the points on the graph in your book, that might be faster and obviously will be more accurate because I don't have graph paper. I'm just making it quickly. And because the numbers are so large in your y, this axis counts by 10. All right, so the first one, 1 and 30. Go back to the origin, 2 and 60. Origin, 3 and 90. Will this be a linear equation?
Yes, ma'am.
It will. Does anyone have a question?